Asbestos, a hazardous chemical. You might have heard about it. You might have even seen it. It is one of the most dangerous hazardous chemicals on Earth. And this is asbestos. Today, I will be talking about how asbestos is found, how it is formed, how to deal with it, and its effects on the human body and the environment. With the importance of answering our focus question, how can we prevent, limit, or resolve the accumulation of harmful chemicals? First of all, we need to understand where it comes from and how it is synthesized. Asbestos is a generic commercial term for a number of 6 naturally occurring hydrated fibrous silicate materials mined from the earth. Their fibers are too small to be seen by the naked eye. They do not dissolve in water or evaporate. Because of the fiber's strength and resistance to heat and chemical or biological degradation, asbestos has been used for over 100 years in a variety of building construction materials and a wide range of manufactured goods, which is one way to identify if it's there. It can still be found in some limited materials today. However, regulatory agencies such as the Environmental Protection Agency and the Occupational Safety and Health Administration, OSHA, recognize 6 asbestos and asbestiform minerals. These asbestiform minerals differ in size, shape, and chemical constituents. They are long, thin, fibrous crystals that are durable, incombustible, and chemical resistant. The most common of them is chrysotile, also known as white asbestos or serpentine asbestos. The fibrous form of the mineral serpentine is best known type and accounts for 95% of all asbestos in commercial use. Chrysotile comes from the Greek word hair of gold, a fibrous variety of the magnesium silicate with a chemical composition of Mg3Si2O5OH4. Therefore, it is composed from forsterite, silica, and water. Here is its balanced equation. As you can see, on one side we have the chrysotile, and on the other we have the forsterite, silica, and water. This can only occur by breaking down and dehydrating the chrysotile at 750 degrees due to its chemical properties such as its strong resistance to heat. So now that we know a bit more about asbestos, more specifically chrysotile, how does this chemical impact a targeted system such as human health? Well, the International Agency for Research on Cancer, S.R.C, have classified chrysotile as well as the other forms of asbestos as a known human carcinogen. Inhalation and ingestion are the primary routes of exposure. So, 3 of the major health effects associated with exposure to asbestos are lung cancer, mesothelioma, and asbestosis. But how do these threats to human health occur? Well, take for example when a worker does a renovation on a house that has old construction material, like homes with popcorn ceiling. The danger is releasing the asbestos fibers in the air from the popcorn ceiling, because if a worker inhales asbestos for a prolonged period of time, the asbestos fibers enter the mouth and nose and flow down the air passages deep into the lungs. The fibers lodge in the lung tissue, and then the immune system cells try and break down the asbestos fibers, resulting in lung scarring, also called fibrosis. Asbestos fibers can remain in the lungs for long periods, and the scar tissue that results continue to develop for many years after exposure. This subsequently causes lung cancer and mesothelioma, which is the cancer of the pleura, the covering of the lungs. This is just one of the many examples of the threat of asbestos exposure on humans, and has been seen before in schools, asbestos mine, construction workers, and on industrial workers. For example, 3,200 new cases of mesothelioma are reported each year by the CDC due to asbestos. However, these symptoms can take 30 to 50 years to develop. Symptoms include shortness of breath, chronic cough, pleural effusion, chest pain, and weight loss. So this leads us into our quantitative and qualitative observations of how chrysotile and asbestos react on the human health. Well, as we saw before, asbestos goes into lungs, the scarring and fibrosis that eventually affects the oxygenation within the lungs, resulting in chronic lung disease that fatally end into lung cancer and mesothelioma, the cancer of the pleura, and leads eventually to death and disability, are one of the qualitative properties we see. This is in addition to the qualitative properties of the symptoms such as shortness of breath, chronic cough, pleural effusion, chest pain, and weight loss. And the quantitative values that are collected from the impact on the target system is that it takes approximately 30 to 50 years to develop. Asbestos has been used for major building materials such as spray-on fireproofing, spray-on soft acoustic materials, spray-on soft thermal materials, and pipe and boiler insulation. But they have caused nothing but negative impact in the community, causing mesothelioma, lung cancer, and asbestosis for many, and killing many throughout the years. So the question still remains, should this chemical be in use? Definitely not. And therefore, in order to answer the focus question, how can we limit the use of these hazardous materials, or how can we eliminate them at all, regulatory authorities should set up to enforce safety standards and to protect consumers in the market. Secondly, they should educate the public on hazards of asbestos and the safe handling of asbestos-containing materials. And we also must ensure that industries label materials that contain more than 1% of asbestos and identify these products as hazardous materials and implement safe handling of these materials. We should also ensure at workplaces that all workers have respirators and protective clothing. And the last but not least is try to limit the use and handling of asbestos containing material.